All right, here we are in week 2, day 3, which is actually Wednesday because there's no school on Friday. So here we have minute 7. It says, which of these shapes does not belong? Well, I can already tell right off the bat. This has 4 sides, 4 sides, 4 sides, 3 sides. So I'm going to put 4, 4, 4, and 3. And I'm going to circle D. Which letter on the shape is beside an acute angle? Is beside an acute angle. So if you're looking at these right here, this is a right angle. This is a obtuse angle. And we have 2 acute angles. So we have this one right here is an acute angle. That's a smaller angle, and so is that one. So for minute 7, when it says which one of these is beside an acute angle, it would be this one, A. I would accept D. I'm not quite sure why A is and D isn't. Okay. They would both work. Which of the following are there could be more than one, that are equal to 1/4? So that means if I divide them, so I was going to divide the top and the bottom. So 5 goes into 5 one time, 5 goes into 20 4 times. So that one works. This one we're going to divide the top number into the bottom number. 7 goes in top and the bottom. 7 divided by 7 equals 1, and 7 divided by 21 divided by 7 equals 3. So it would not be B. Then we're going to divide the top and the bottom both by the 10. 10 divided by 10 is 1, and 40 divided by 10 is 4. So we have another one there. Next one, 12. Divide 12 and 50 both by 12. That is going to get us to 1. And this is going to be that won't work. Because 12 doesn't go into 50, it does go into 60. Now I could say a number that goes into both of those is 2. 2 goes into 12 6 times, and 2 goes into 50 25. But that is not equal to 1/4. So the answer is C and A. C and A both are equal to 1/4. Next one, write a decimal 43 thousandths. So this means 43 thousandths. You have the decimal that goes first, because we're talking about thousandths. So just like we talked about, it goes, if you're on that side of the decimal, it goes tenths, hundredths, thousandths. So if I want 43 thousandths, my 43 has to end in that place. That would mean I would have to have a 0 place holding the front, and then I could write the number 43. 43, and then you say the place, thousandths. 43 thousandths. If A equals 10 and B equals 6, then A plus B equals 16. Is this true or false? Well, I do know that 10 plus 6 equals 16, so this would be true. And I showed my work by just putting the numbers above that. Draw the next shape in the sequence. So first we have 1, then we have 3, then we have 6. Our next one we should have, is it the number we're going for or the shape, you think? So is it that we would go 1 times 3 times 3 times 3, so times 3, or sorry, times 2 would be 6, times 2 would be 12. Nope, we're going for this shape. We're looking for the shape that looks like this. So we're looking for that. Which actually, if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the numbers don't line up the same with that. Sorry, next. It says, what is the perimeter, the outside, of the shape to the right? So that means I have to count every unit's face. So the face is the part that is outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there would be 18 faces on the outside of that shape, which would be 18 units. Now, if I wanted to compare 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 for the area. So the perimeter is double the size of the area. Next. For problems 8 and 9, use the chart to the right. Number 8, which student has the best grade? So if this is 100% being the best, they didn't tell us that, but we're going to say if the 100 is the best and 0 is the worst, which student has the best grade? Desiree. She's closer to 100%. Assuming you're going for, again, 100 being an A. If this was golf, it would not be that way, but we're looking at test scores. Desiree's score was about twice as high as the score for, well, twice means it would be about half. So Desiree has twice the score of Rick. Poor Rick, maybe he just had a tough time. All right. Now, when we're doing long division like this, I'm just going to show you the traditional algorithm. So when you're looking at the traditional algorithm, you're just asking yourself how many times can one number, this number in the front, the quotient, not the quotient, I'm so spacing on the word. The quotient is up here. This is the dividend, and this is the divisor, sorry. So how many times does the divisor go into the dividend? So 3 goes into 6 twice, and I'm super careful. Sometimes I even put lines to line my things up. So I have 2, 3 goes into 2 6 times, 3 goes into 3 1 time, and 3 goes into 6 again 2 more times equally. So my answer would be 212. Next, this part, when we're doing this, I can ask myself, for as far as the dividend, can divisor, this is the dividend, can 3 go into 1? No. Can 3 go into 12? Yes, 4 times. And then can 3 go into 9? Yes, 3 times. So equally. So that would be 43. Now this one, I know right off the bat that this number is not going to be an easy one, because right off the bat, 3 doesn't go into 1 by itself. So I'm going to give myself a little bit more space, and I'm going to write this over here. So can 3 go into 5? Yep, 1 time. 3 take away 5 is a 2. So then I'll bring down my 0. Can 3 go into 20? Yep, 6 times for 18. And 20 take away 18 and give me a 2. And I'll bring down my 1. So I have 21 now. Can 3 go into 21? Yep, 7 times. Exactly. So my answer for this one is 100, and I'm going to put it in a 67. Please do not erase your work. Always keep your work.